Alright, so today guys I'm going to work on putting a chuck on the Vernon Lathe and getting us one step closer to actually making some chips with this machine. So these are the two chucks that came with the lathe. This 3-jaw was what was on the lathe when I bought it, and this 4-jaw was amongst the items that were with the lathe. Now these both do fit the spindle. And so these are really the only two choices I have right now for chucks. If I'm correct about that being a 4.5 Morse taper in that spindle, I'm probably going to have to make myself a dead center at some point, because in searching online I'm finding that apparently the 4.5 Morse is a very uncommon standard, so that's not working out so well. And do I really need one at this point? Not really, because I don't have a what they call a dog drive plate or a faceplate for that lathe. I've got a couple of faceplates. Unfortunately, neither of them fit the Vernon. This one right here, I don't even remember where this came from. This might have been with that other stuff, but I'm pretty sure that I already tried this, and this is, yeah, just looking at this, this has got a, looks like maybe 8 threads per inch. And then I've got a larger one that came with the South Bend that fits the South Bend spindle. I stand corrected. Actually, the one that I just showed you was the South Bend one. That fits the South Bend spindle. And then I have this other one here, which is nice because it's got all these slots on it, but this has got a smaller size and does not fit. Yeah, this also looks like it's 8 threads per inch. I think this one is the one that I found actually will thread onto the Hendy spindle, but I think it's too large a diameter to use on a 12-inch swing lathe. So, and I think it was so close that I had decided that, you know, down the road when the Hendy's back together, I'll try putting this back on and seeing. This might just fit on the Hendy, which would be, that'd be nice. But anyways, so for this lathe, no faceplate, no drive, dog drive plate, which a dog drive plate, I think I have one for some other lathe. Alright, so this is a this is a dog drive plate. And what this is for turning between centers. So what you would do is you would insert your dead center into the spindle, and you'd have your drive plate on like this, and then you'd have your piece of stock supported between centers, and then you drive it by putting what's called a lathe dog, one of these things, on here, and this gets clamped onto the workpiece, and then this little arm sticks out and is driven in this slot right here. So this is how it gets turned. So for turning between centers, this is the kind of setup you would want. But again, problem is I don't have one of these for the Vernon, and I don't have a dead center that fits the Vernon spindle anyways, so that's not going to happen. Why do you want to turn between? Why would you want to turn between centers? Well, what's great about turning between centers is once you get everything set up, if you have to remove the part to take a measurement or do another operation on it, you can put the part back in and everything will still be pretty much intact as far as settings go. With a 3-jaw chuck, if you have a piece of stock mounted in here and you do an operation on it, a turning operation on it, the concentricity will be destroyed if you take it out of the chuck and then put it back in again. So then in the next operation you won't be turning concentrics to that first diameter that you turned. Does that make sense? So for the time being, all I have available to me are these two chucks as far as this lathe goes. Unless I change, or make, I should say, unless I make a backing plate for make a backing plate that will fit the Vernon and then put it on another chuck. But as far as large chucks go, I only have these two. I have a, I believe a 4-jaw that's thicker than this and seems like a beefier, better quality chuck than these for the Hendy, and it's the only chuck I have for the Hendy, and I'm actually glad that it's a 4-jaw, and I'll explain that in a moment, why I prefer to have. General rule of thumb, if you are only going to have one chuck for your lathe, you want a 4-jaw over a 3, and I'll explain that in a moment. So, I've got that, and then I've got this really old large chuck, which I don't even know if it would fit on the swing of the Vernon, and I don't even remember what that's got for threads on the back of it, and that doesn't have a backing plate, so the threads in that chuck, basically that chuck can't be modified to really fit. Well, I guess technically you could bore it out to a larger size, but that's a really old chuck, so I took that because it was going to get scrapped. I actually initially thought it fit the Hendy because I found it with the Hendy, but I think the guy who owned the Hendy just got that from somewhere and never did anything with it. Might even make a good candidate for a rotary welding table chuck or something like that. And that's out in the shed, so we'll forget about that for now. So 2-jaw, 3-jaw versus 4-jaw. All right. So these are obviously two different manufacturers also. It looks like this 3-jaw is pretty well used, and the 3-jaw, the simplicity of the 3-jaw is why it's so popular, because basically when you turn this with the chuck key here, all 3 of these jaws move out together, and the way that happens is there's a scroll mechanism inside here, and the back sides of these bases that these jaws are mounted on actually have, they fit into the scrolls, and so that's how it moves in and out. Now, there's 2 basic styles of the way these jaws work on these scroll chucks. On some scroll chucks, the actual jaw itself, the back of the jaw actually has the scroll, that the male part of the scroll that engages the grooves on the scroll inside. On those chucks, you can't reverse the jaws. Okay, so what typically happens with that style of chuck, is that you have a second set of jaws, that when you want to change the jaws, you actually rotate this all the way out and the jaws will come out, and then they're actually numbered. They're actually numbered 1, 2, and 3. And this is stamped, and you can actually see there's a 3 there, there's a 1 there, and there's a 2 here. Well, I can see it, you guys can't. So if I want to take these out, I always want to make sure that they go back in the right place. So this is number 2 over here, and that's in number 2. And this is number 3 over here, and it's in number 3. And by process of elimination, I know this is the final one. Now, the beauty of this 3-jaw chuck, what I lucked out on this one, why I lucked out on this one, is because these jaws are removable without taking the scroll part out. So if I want to reverse the jaws on this chuck, all I need to do is remove these cap screws, flip the jaw around and screw it back on, and voila. So why would you want to remove the chuck and do that? Well, because there are actually serrated edges here and here that allow for you to hold a larger diameter on the outside by flipping these around. Okay, so that makes this more versatile, or I should say not necessarily more versatile, but it definitely makes it a lot easier to change the jaws on this to the other configuration than the type that has a second set of jaws. The other problem with the type that has a second set of jaws is if you buy a chuck used or acquire a chuck used, oftentimes that second set of jaws has gone missing. And in fact, I have a whole, probably half a dozen or more just spare chuck jaws that I've picked up in some of my excursions, and those obviously should have gone with the chucks that they belong to, and were separated from their mama at some point, and bad things happen. What are you going to do? So why do I keep those? Well, because the step, if you lay one of these down, you can actually use it as a standoff on like a milling table or something like that. At least that's what my thinking was when I grabbed them. And who knows, might get absolutely crazy lucky and it might fit some of the smaller chucks that I have, I don't know. So we've got the 3-jaw, and then we've got the 4-jaw. Now, the pros and cons of the 4-jaw. Well, the 4-jaw, because of the nature of the beast, the fact that these jaws are not locked into a scroll, these jaws each are rotated independently. In other words, there's a separate place to put the chuck key on each one of these jaws and move the jaw in and out. For that reason, these jaws, you unscrew them all the way to reverse them and then screw them back in. So this is also these are also reversible jaws. And again, you don't need a second set of jaws because you're using the same jaws. They're just flipped around. So that's all fine and dandy. And you can dial this in to a much greater degree of accuracy than you can with the 3-jaw. The problem is that's more time consuming. So this is faster, but this is more accurate. And depending on how worn this chuck is, you know, it could be pretty far out of whack. And in that case, you're gonna, you know, if the wear of the scroll isn't the issue, you could regrind these jaws. But what happens is these from clamping, from years and years of clamping on parts, this end right here gets a little wider. It's called bell mouth because basically you can imagine the shape of a bell. It gets wider at the bottom. So I'm getting kind of off the subject as usual. So I've got this 4-jaw, so I'm tempted to put the 4-jaw on. The only thing I don't like about the 4-jaw is that this is a much older chuck and it doesn't seem like it's the same quality. If you look at the back of this chuck is actually hollow. So that makes this chuck a lot lighter and easier to manage as far as taking it on and off, which is a plus. But as far as, you know, the quality, it just seems like this is a more solid, better made chuck. And if you were to ask me, well, who makes that chuck? I would tell you that I do not know because it's dirty enough that I can't quite see. And there is something there, but I can't quite see who the maker is on this. So we may never end up knowing who made this chuck. Unless somebody who's watching this video has a really sharp eye and is very good at identifying this kind of old stuff. This, by the way, is the backing plate right here. So this, if you remove these 4 bolts, you can actually take this backing plate off. And then I could take this backing plate, and if I found a chuck that it fit correctly, I could actually switch this to another chuck. Or, consequently, if I wanted to use this chuck on a different lathe, I could make one of these backing plates for that lathe and put it on here. So there's plenty of videos on YouTube of, you know, people doing that. So I think what I'm going to do is I'm going to clean some of these chips and everything out of this chuck. This is also, obviously he was using this, and this kind of got thrown by the wayside and forgotten about because this is A, filthy, B, the back side here that's hollow. I can even see mouse turds and stuff down in there. So this was just laying on the floor underneath that lathe for years and years and years. So we're going to probably put that one back to bed, depending on how well this one works out. So I'm going to clean out the chips that I could see down in there. In the How to Run a Lathe book that South Bend put out, I actually saw a picture of a tool for cleaning out these large grooved threads on a chuck before installing it. And it was actually just kind of like a 90-degree, let's see, it was actually like, imagine one of these that came down, went to a coil for a spring effect, down to another one facing this way. so that you could actually pinch it to squeeze it down to get it to fit into the diameter of the grooves, and then rotate it and have those two opposing fingers go in there and clean out your grooves. I wonder if they still make those. Alright, looks like I'm getting to the point where I'm not getting any more swarf to come out as I do this. So that should be pretty clean. There's an area in between here that I can't get into without taking the backing plate off the chuck. You know, and maybe at some point I'll do that. But for right now, for my purposes today, I think we're clean enough. Alright, so I just put a couple of drops of oil on the threads of the spindle nose, and I put a nice piece of oak board there. It doesn't have to be oak, obviously, but you do want some kind of a board down there to protect your ways. Now on the Hendy lathe, when I went to remove the chuck, when I was taking the lathe and moving it, I couldn't get the chuck off. And what I found on the Hendy lathe was that on the back side here, there was a hole, recessed hole with a set screw in it to actually help lock the chuck onto the spindle, which was interesting. I don't know if that's something somebody added or if that was, you know, commonplace. Oh, by the way, also these mating surfaces here between the back plate of the chuck and this base of the nose of the spindle here, it's critical that those are clean. If you get a little chip or something in there, it can actually throw the whole chuck off. So, now, as long as this lathe is turned in the conventional direction, we don't have a problem. If you have a drum switch that allows the rotation to be reversed on the lathe, on this style of a mounting, you got to be real careful, because if you, especially if it's in a higher speed, if you inadvertently hit the drum switch in the wrong direction, what can happen is this lathe can unscrew and very suddenly and violently fly off. And because of the mass that you're dealing with the weight of this thing, you could get really injured. So that's something I just thought I'd mention. And of course, with more modern lathes, we don't have that problem. And when I say modern, I mean you don't have to get much newer than this. Well, maybe, but you know, the point is this thing's like 100 years old, and if we were to go back, say, 50 years or so, we'd get, you know, the better style of mountings coming in, like the L taper or cam lock, in which you actually have some sort of facility to positively lock that chuck onto the spindle so that it can't, no matter, you know, how many times you reverse it, doesn't matter which direction it's going in, it doesn't necessarily have to tighten more if you're going in one direction and loosen in the other direction. It's not relying on a thread. It's relying on, well, in the case of the cam lock, you've got locking pins. In the case of the L taper, you've got a taper that the chuck slides onto, but then there's a locking ring on the back side that actually draws it onto the chuck and locks it. So, and that's gonna, typically the L taper will have a keyway. So that's where the fact that it can't just unscrew on you if you go in the opposite direction. That's where that comes in. Alright, so what's wrong with this picture? Well, I'll tell you what's wrong with this picture. Somebody's gone and left the chuck key in the chuck. Seriously though, this is a major issue of safety. The chuck key being left in the chuck. You can imagine if you absent-mindedly started the machine with the chuck key in the chuck, this thing now becomes a projectile, and you know, you might think, oh gee, it'll fly off that way. Well, then it'll bounce off the wall, and or if it's, you know, if you happen to have tightening it here. The point is, you don't want to send this thing flying. Very dangerous. So the whole idea is that at all times you want to be aware of where this key is located. And I'm even thinking I might do something to mark this in a way so that it really kind of sticks out like a sore thumb. But whenever you walk away from the machine, probably a good idea to take the chuck out so you don't you know. The other thing, the other thing you can do is you can have a dedicated place for the chuck to be. In other words, you know, whether it's mount a, you know, have a place for it to store, and that way you can make a habit of having a visual cue of seeing, you know, gee, is that chuck where it's supposed to be? Maybe even over by where the on switch is. You go to put your hand over onto the on switch and the chuck's not where it's supposed to be in its holder. All of a sudden it's like, whoa, where is it? Oh, it's on the back side here. I forgot it was there. Alright, so the jaws are clean. So what I'm going to do now is I'm going to find I've got some of these dowel pins, which I know are precision ground, and they're hardened steel, so they're not going to really, the jaws aren't going to really be able to bite into it, but I'm not going to try and turn on them. All I want to do is mount them in the chuck so that I can put an indicator on it and just see how it runs. Alright, so I have a dowel pin in there clamped, and I have, this is sort of like a best test indicator. It's a 1/1000th indicator. I forgot who makes this one, but it was one I had handy. So it's got a little ball on the edge of the probe there, and the ball right now is touching the back, almost bottom edge of the dowel. And the dowel, of course, being very smooth, I shouldn't get any problems where any bumps or anything are causing any fluctuations in the reading. I've got the lathe set. I don't think I have the back gearing. Yeah, I have the back gearing gauge, so I've got it running really slow. So I'm gonna, doesn't look like I get any clearance issues. My chuck key's not in the chuck, so let's fire it up. Well, that was weird. Well, there's a problem. My indicator's loose. Okay, I've reset and even zeroed this, and by putting a tiny bit of pressure down, I can see that I am in contact with the bottom of the dowel, so let's try that again. So it's moving about 2 divisions, and because this is a 1/1000th indicator, that would indicate that this is running out of true approximately 1/1000th of an inch. And I'll tell you what bothers me more than that. When I put my finger on this, I can feel a vibration that is not pleasant. I wonder where that vibration's coming from. It's an uneven vibration. In other words, if it were a sound, it would be going so what's going on there, I wonder? Well, we don't want vibration in there, because I believe that's going to result in chatter. Alright, well, rotate this by hand. I'm going to unplug the power. And I'm just going to rotate this outer pulley by hand so that I can... Well, see, now I would actually want that gearing up higher. Oh, duh. That's right. I got the chuck on now. So I actually, before when all I had was the spindle, I had nothing to grab onto. Now I've got the chuck. I can actually put the key in and use it to rotate the chuck. So, let's see. Ooh! That's unscrewing it, doofus. So if I disengage the back gear and I don't put the locking pin back in, that allows this to freewheel. So I don't even need the key. That's so easy to turn, I don't even need the key. Idiot. Alright, let's try that. That's at about half a division past 0 up to half a division past the 5 mark. So that's 4 divisions. So it's running out 2,000ths. Of course, if I try and turn this to 0, that's the low spot there. I'll probably end up disturbing the darn thing. There you go, 0. Ah, see? Look, it goes back down below 0 now. It's that touchy. Well, you get the gist of it. So that's the run out. Which, I don't know, for a chuck this age, maybe 2,000ths is not that bad. Alright, so what's wrong with this picture? Take 2.